Welcome to EPG Part-37-Digital in Computer Science, series of lectures on computer networks. So, we have been looking at some wireless networks and wireless technologies. So, as part of looking at some common wireless technologies, we will be looking at Bluetooth today. So, we will look at the Bluetooth protocol, the various components that are there in Bluetooth, how the connection is set up in Bluetooth and other details of this particular protocol. So, Bluetooth, as we all know, it is used for very short range communication between mobile phones, PDAs, notebook computers and so on, with other personal or peripheral devices. Basically, the idea is to replace cables and which are connecting electronic devices. Okay. So, it operates in the license exempt band of 2.45 gigahertz with FHSS, frequency hopping spread spectrum. The range is limited only about 10 meters. And the communication devices typically belong to one individual or group, which is why we sometimes refer to it as personalized area networks or PANs. Okay. And now you have version 2.0, for instance, supports speeds of up to 2.1 megabit per second. One of the key factors of this is very low power consumption. So, that is the very important characteristic of the Bluetooth technology. Okay. So, the Bluetooth specification actually is given by an industry consortium which is called as the Bluetooth Special Interest Group. Okay. And what they specify is not just a layer 2 kind of mechanism or the link layer mechanism, but a complete suite of protocols, entire suite of protocols, including application protocols which they refer to as application profiles. So, these application profiles, for instance, could specify how to synchronize a PDA with a personal computer, or you could have another profile which talks about how to connect a mobile computer with a wired LAN and so on, right. So, you have different application profiles which are specified as part of this Bluetooth. So, coming to the Bluetooth technology per se, the term that is used when two or more devices share the same channel to talk to each other, that is called as a piconet. Okay. It is a piconet that is formed. So, a piconet normally consists of a master device and slave devices. Now, it can have up to 7 slave devices, and any communication is only between the master and the slave. Okay. The slaves do not communicate directly with each other, right. So, they will, if at all they have to talk to each other, it will have to be through the master. A slave can be also in a state called parked, which means that it can be set to an inactive low power state. Now, this is important because power consumption is one of the key features of the Bluetooth protocol. Okay. So, then we can also have 2 or more piconets which are interconnected to form what is called as a scatter net. So, you can see this. There are 2 different things which are interconnected to each other. So, that is also a possibility that we have. Okay. So, this is your one master here connected to this piconet, this handling this piconet, and it is connected to this piconet. So, this interconnection is referred to as a scatter net. Okay. So, now we talked about a master and a slave. See, these are 2 important components here. So, what is this master device supposed to do? The master device in a piconet is the one whose clock and the hopping sequence, it has a frequency hopping mechanism that we said is used. So, the hopping sequence, the different frequencies that are used, right. So, that hopping sequence and the clock, okay, of this particular master device is what is used to synchronize all the other devices which are there in the piconet, that is all the other slaves. So, it also carries out what is called as the paging procedure and the connection establishment. We will be looking at how the paging and connection establishment are done shortly. Okay. So, you can look at it as saying that it allows the slave devices to connect to it, identify where the slave device is and be able to send data to it. So, that is what we mean by this process. Okay. Now, the slave devices, they are defined as those units which are synchronized to the master via the master's clock and hopping sequence, and after connection establishment the slaves are normally assigned a temporary 3-bit number, okay, which is, so you can see 3-bit number would mean that you can go only from 0 to 7, which is why we have about 7 devices which are supported in the in a piconet. Okay. So, it is basically to reduce the number of addressing bits that are required. Okay. So, now when you talk of these piconets, so it is essentially a master-slave relationship that is supported. So, a Bluetooth device can either function as a master or as a slave. You would have seen this when you are for instance using Bluetooth to connect up to mobile devices, right. One can will act as a master, the other can act as a slave. Any of them can act as a master and any of them can act as a slave. And a piconet is formed when you have the network with one master and more than one or more slaves. Okay. And each piconet is defined by a different hopping channel to which the users will synchronize to. Okay. And each piconet has a maximum capacity of about 1 megabit per second. Now, of course, you have slightly higher data rates are supported. and the hopping pattern is determined by the master. Okay, this is the, so if you look at a piconet structure typically, so you can have a master, and then you could have an active slave, you could have parked slave, and you could have other slaves which are at a standby mode of operation as well. Okay. Okay. So now coming to different link types that are supported. Okay. At the physical link, there are two types of physical links that are supported on in Bluetooth. So one is called as a synchronous connection oriented link. So what we mean by this is that you have a point-to-point full duplex connection between the master and the slave. So this is established once by the master and kept alive till it is released by the master. Okay, so this is typically used for sending voice connections, so to guarantee continuity. So once you are connected, you maintain that synchronous communication. Okay. So what happens here is, now since Bluetooth actually uses a time division multiplexing or duplexing kind of operation to use the channel. So the master, which means there will be slots in which the data transfers will take place. So the master will reserve slots which are used for the SEO link, so that you can make sure that you are able to preserve any time sensitive information. You are able to give some guarantees for sending the time sensitive information, which is why we said it is normally used for audio, video and so on. Then you have another link called the asynchronous connection link. This is a momentary link between the master and the slave. So no reservation of slots takes place here, and it can also be a point to multi-point connection. Okay. So symmetric as well as asymmetric links are possible, which means one direction could be different data rate and other could be different data rates and so on. Okay. So if you look at the ACL, the asynchronous connection list, is designed basically for data traffic and packet switch connection where data is exchanged sporadically as and when data becomes available. Okay. So data integrity in this case is normally checked through some error checking, and a retransmission is done if there is an error. And normally there is one ACL link between a master and a slave. Okay. So that is what happens in ACL. In SEO, the synchronous connection oriented mechanism, this, as we said, is intended for time bounded information such as audio or video, right. So it provides, you can say, a circuit switch kind of a connection where data is regularly exchanged. It is not actual circuit switching, but you can look at it as something which like circuit switching, which is able to provide you the guarantee that you will get a slot for the data to be sent. So here retransmission is not necessary, so it is not, because normally it is expected for real time data. Okay. And you can have up to 3 SEO links per piconet, right. So that is the two different links that are supported. Now coming to the protocol stack that we have in Bluetooth, as we said, Bluetooth specifies not just a link layer protocol, but an entire stack of protocols, okay, starting from the application layer. So at the application layer, you can have different profiles, so different software modules that are there. And then you have, you can see there is an SDP protocol, there is a PPP, RFCOM, HCI control and data, right. So all these are different protocols that you have you can say at a higher level. So the L2, okay, so then the HCI control is used for to control the Bluetooth, it is the interface to control the Bluetooth chip. SDP is a service discovery protocol. It is used to query the peer devices, to discover and query the peer devices. RFCOM is used as a to emulate RS-232 cable connection. Okay, that is the purpose of the RFCOM protocol here, right. And the L2 cap, that is used for channel establishment for higher layer protocols. And this set that you have here, link manager protocol, baseband and RF, right. So the LMP, this link manager protocol, is used for the, that is the one that is used for the baseband link configuration management. So baseband is used for device discovery and link establishment, and RF of course takes care of the radio characteristics. So this is basically, these are normally implemented on the Bluetooth chip as such, and the others are available as software modules. So that is normally how this protocol will be implemented. Okay. So this lower category here, this box here plus the L2 cap audio, right, that is normally referred to as the transport protocol group. So the RF module here is responsible for sending and receiving modulated bit streams. So baseband, as we said, is responsible for defining the timing, framing, flow control on the link and so on. The link manager is responsible for managing the connection states and for enforcing fairness among the slaves and for doing power management. And then you also have a logical link control and adaptation protocol, the LLCAP. So this is used for handling multiplexing of higher level protocols. And then similarly segmentation and reassembly of larger packets at the higher levels. So segmentation and reassembly will be handled by this LLCAP protocol. and it's also responsible for device discovery and quality of service. Okay, so you can see that we have actually a set of protocols which work together in order to provide the Bluetooth services. So if you look at the packet structure, each packet actually is a small packet that we have. So you can see that there is, it starts off with a 72-bit access code, and then you have 54 bits of a header, and that's followed by a payload. The size of the payload is variable from 0 to 2744 bits. Okay. So this payload could be used to carry voice. Now we said that if it is voice that's being carried, normally it's real-time data, so you will not have any error checking mechanism. So no CRC will be used, and no retries and retransmissions will be normally used with voice. Whereas when you are using other data, for other data you will have a header and you will have a CRC, so which means you will do a CRC check, and there will be an automatic repeat request for, and retransmissions will be done. And you can also have a frame FEC, which is an optional mechanism. Okay. So this is the normal structure of a Bluetooth packet. Okay. So now we talked about something called an access code, right? So what would this access code consist of, and what is its purpose? Purpose of the access code is basically to provide synchronization, identification and signaling. Okay. So if you look at different types of codes, access codes that we have something called a channel access code. So CAC. So the channel access code identifies a particular piconet. It's a piconet identifier kind of a thing. Okay. Then you have a device access code. So this is used for signaling procedures like paging, response paging and so on. Okay. We will see what is meant by paging and all quickly. Then there is something called an inquiry access code or IAC. So in inquiry access code we have two access code, one called a general IAC, GIAC, which is common to all devices, and there is something called a dedicated IAC, which is for a particular dedicated group of Bluetooth devices. So that is called as a DIAC. Okay. Right. So if you look at the how the connection is established, there is a interesting state machine that is used to control how the master and the slaves talk to each other, how they discover each other, how they connect to each other and start sending data. Okay. So you can see that these are various states. There are many other substates also which are used along with this. So major states as such will be, could be in a standby state, and or it could be an inquiry state. This inquiry and page are on its way to go to the connected state. So from the standby state through an inquiry and a page state, it moves into the connected state. So in the connected state, it could either have, it could be in a mode where it is parked, or in a mode called hold state, or in something called a sniff state. Okay, these are other possibilities that you have, and it will be transmitting data, and once it is done with that, it will go back to the, it can go back to the standby state. Okay, so we will look at some of the details of how these things take place now. Okay, that's a very interesting aspect of this. Okay, so now we said there are some substates that we have, right, when we talk about this inquiry and so on. So inquiry basically is to identify, inquire and find out which are the devices which are available in that region. Okay, so we have something called an inquiry scan which is used for that purpose. So what actually happens in the inquiry scan is that a device that wants to be discovered, which means a device may also choose not to be discovered. Okay, so a device which wants to be discovered will periodically enter into this mode, and it will listen for inquiry packets. So it is scanning for inquiry packets to come. Okay, that is what we mean by an inquiry scan state. Okay, so the inquiry state is a state where the device will send an inquiry packet. Now this inquiry packet will be addressed either to the general access code, or it will be for a dedicated IAC. Okay, so the inquiry access code. Now this transmission will be repeated on the inquiry hop, sequence of frequencies, which means it is not just once that will be sent, it will actually be sent on a sequence of frequencies. Okay, that's a very interesting part of this. Okay. And in response to this, there will be an inquiry response which will be sent. So this is sent by the device which is being inquired, right? So which means when an inquiry message is received by a node which is in the inquiry scan state, it forms what is called as a response packet, an FHS packet, which contains the responding device address, okay, and it will be sent after a random number of slots. Okay, so that is what will happen in the inquiry response state. Okay. Now the main idea that is used behind this inquiry state, if you see, is this use of various frequencies. Okay. So we said that the inquiring device will send out an inquire sequence, right, or an inquire message as such, on 16 different frequencies. So which is called as a 16 channel train. Okay, that is the term that is used. So the receiver which is actually in a standby mode moves to an inquire scan mode. Okay, and it performs an inquire scan for a period which is long enough to be able to get this scanning that is taking place, right. So, long enough for an enquiring device to send that enquire on the 16 frequency. So, it should be able to receive those enquire messages that are being sent. Okay. So, the receiver will do an enquire scan frequently enough, so that it is guaranteed to wake up during a 16 channel train. So, remember the receiver can go to a standby or a sleep mode, right. So, it should be able to come back and connect when somebody is enquiring to find out if some nodes are available, it should be able to connect to that. Okay. So, that is the reason why it will frequently move into an enquire scan state, look for enquire messages and then go back to its normal state or a standby state. Okay. So, you can see that what will normally happen, you have different slots as we said. So, there will be and you can see that the inquiry channel will happen on different frequency channels. So, you will have first on channel 1, then channel 2, channel 3 and so on, right. So, different slots. Okay. So, that is the way it will be transmitted. Okay. So, we talked about the inquiry response, right. So, when a device receives the enquire, so it will wait for some time between 0 to 0.32 seconds before it sends out its response packet. Now, why should it wait for a random amount of time between 0 and 0.32 seconds? Again, this is to make sure that you avoid collisions, because remember, when an inquiry is sent, more than one device could be responding to it. So, if more than one device is responding and both respond simultaneously, a collision will occur. So, to avoid the collision, they use a random period to respond to this particular enquire message. So, this FHS packet will consist of a device ID and a clock. Okay, that's the information that is required to connect to the to kind of identify that particular device. Okay. So, after the enquiring radio, right, is done with the enquiring procedure, what will happen is it will have got the FHS packets from all the nodes which are responding to its enquire. So, it will know the radios, it will know the IDs of all the devices which are within that particular range. Okay. So, that is what you have. So, this is typically what an enquiry message will look like. Okay. So, this device, let us say, is the master just sending out an enquire message, right. So, you will see that it will keep sending out enquire messages with maybe with higher this thing. So, the moment its range covers certain other devices. Now, these devices will receive this enquire message. So, when they receive the enquire message, right, so they will send back an enquiry response. Okay. So, that is to indicate that they have now send this inquiry response to this particular device. So, their information is now available with this master that you have here. Okay. So, then after the inquiry happens, now with the inquiry what has happened is that it has just discovered the different devices. You still not decided whether you are going to start talking to those devices as such. Okay. So, that happens only in the next phase where we use what is called as a page mechanism. Okay. So, what happens in the page state is that the master will use that clock information which came from that slave device when it enquired it, right, about the slave to be paged to determine where in that hop sequence the slave might be listening in the page scan mode. Now, remember there are different frequency hop, there is a sequence of frequencies that are used. So, you need to know on which hop sequence the slave is going to connect to the master. Okay. So, that information is obtained from this clock information. Okay. So, the master now will send a page message after it has determined that, okay, and the slave will be in what is called as a page scan mode. So, what is a page scan substate? This page scan substate indicates that it is listening to the page messages that are coming from a master. So, waiting for page messages which are coming from a master. Okay. So, it listens to the packets that are addressed to this particular access code. Okay, that is a dedicated access code. So, on receiving, so when in the page scan, when it receives a page message, okay, the slave will now enter into the page response substate and send out a response message. So, it sends back what is called as a page response, which will consist of its ID packet, which will contain its DAC, its access code, and then the frequency for the next slot. It will send this page response frame at the frequency for the next slot from the one on which it received the page message. Now, I will tell you why this is very important. So, what we actually see is that since we use a time division multiplexing, right, the way the time slots are handled in Bluetooth is very interesting. So, what happens is the master and the slaves will alternate use of the time slot. So, which means if the page is sent on a particular time slot, the response will be sent on the next slot. Okay, that is what we mean by saying that it is sent at the frequency for the next slot from the one in which the page message was received. Okay. So paging is something like saying, will you connect to me? Okay, so it's similar to inquire. So you have still not synchronized the clocks or frequencies. Okay, so this is where the actual piconet connection with the device is being established. Okay. Now this connection process actually involves a 6-step process. So the first step is where the a slave ID, a message which consists of the slave ID, is sent from the master to the slave. Okay. So it uses the hopping pattern of the page, alright, and the pattern source and clock are that of the slave. So slave similarly you have another slave ID sent from the slave to the master. Okay, it's a response, page response. You have a page and you have a page response. Then there is an FHS which is sent from masters to slave, and then slave ID from slave to master, which again is a response, and then the first master packet which goes from masters to slave, then first slave packet which goes from slave to the master. So this sequence of steps are followed to complete this paging process. So once this is done, the communication is established between the master and the slave, and they can start transferring data to each other. Okay, so that's what is used. So this is just an example of paging. So you can see that once the paging messages are sent out, the response will be sent back by the from A to, so let's say for instance A and B are getting connected here, right. So that's what we are trying to show over here. Okay. Okay. Now there are we said that power is a very important aspect, right, because Bluetooth is meant to be a low power protocol. So there are various power control modes which are used in Bluetooth. Okay. So we have something called a sniff mode. So this is a low power mode in which the listening activity of the slave is reduced. Okay. So you are trying to save power by reducing the listening activity. Okay. So what happens here is that the slave will listen for transmissions only at fixed intervals. Okay. This fixed interval is T sniff at a particular offset slot called D sniff, and it will do it for n sniff amount of times. So the number of times it will listen to the channel, and at what slot it will receive. Okay. All these are basically parameters which are given by the master when it issues a sniff command to the slave. So which means it can tell the slave that you can go into sniff mode now and just listen to the transmission at these periods alone. So you can be in a low power mode until then. So that's the idea that's used in the sniff mode. Then we have something called a hold mode. Now in the hold mode, what happens here is that the slave temporarily does not support any ACL packets, right. So we talked about two different, the asynchronous control link and the synchronous control, right. So the ACL packets are not supported. The SCO links may still be supported. Okay. So for a particular amount of time, say T hold amount of seconds, it could go into the hold mode of operation. So what we do by freeing it from doing any this kind of transmission is that you are making it free to do other things like do scanning or paging or inquiring with respect to another piconet. It can also connect to another piconet. So you need some time for it to be able to connect to another piconet. So that is what is facilitated by this hold mode of operation. Okay. But the slave will still keep its active member address, that is it has normally each member is given an active member address. So it will still hold on to that active member address, which means it is still part of this piconet as such. Okay. So another mode that we already referred to earlier was a park mode, right. So this is a very low power mode with very little activity. Okay. But the slave is still be synchronized to that particular channel. Okay. And the parked slaves will regularly listen for beacon signals at certain intervals, and these intervals are decided by the beacon structure which is communicated to the slave during the start of the parking. Okay. So the parked slave has to be informed about a transmission in a beacon channel which is supported by the master to keep the parked slaves in synchronization and then send them any information. So which means we need some mechanism to inform the parked state that it is going to receive some information. Okay. So any message to be sent to a parked member is normally sent over the broadcast channel. So it also helps the master to have more than 7 slaves, because you can have actually, because if it goes into the parked mode, you can, and you are after all sending it in a broadcast manner, right. So you can indirectly support more than 7 slaves. Okay. So now we have been talking a lot about the frequency hop spread spectrum. So how exactly does the frequency hopping take place in Bluetooth? If you look at that, the Bluetooth channel has actually a pseudo-random hopping sequence through 79 RF frequencies. Okay. So there is, you have a band from 2402 to 2480 which is divided into 79 different frequencies, and where the channel spacing is of 1 megahertz is the spacing. So it will hop at a rate of 1600 hops per second. Okay, so that is the different channels that we will have as such. Okay, so the nominal hop rate will be about 1600 hops per second. Okay, and that is so you can see this figure which gives us the time versus frequency. At different points of time you will be at different frequency will be used, and it is a random sequence, right. So which is why we say it is a pseudo random hopping sequence is used. Okay. So for every packet there is a hop that will take place, a different frequency will be used. So packets can be 1, 3 or 5 slots long. Okay, that's we said that slots are used, right. So packets are normally pretty short. So you can see here that if this is using fk, right. So the next slot will be, master is using a frequency of f of k, the next slot will be used by the slave. So fk plus 1 will be used by the slave. The next slot will be used again by the master, fk plus 2. So you will see that the master will get to use every alternate slot as such. Similarly, the slave will get to use alternate slots. Okay, and the duration of a slot is 625 microseconds. So that is the way it is handled. Okay. So and we said that it also uses a time division duplex scheme, this alternating of the slots between the master and the slave. So let us see how that happens. So as we said, the channel is divided into consecutive slots of 625 microseconds. So and one packet can be transmitted per slot. Okay. And we said subsequent slots are alternated for transmitting and receiving. So which means you have a strict alternation of slots between the master and the slaves. Now the master can send packets only in even slots. So you can send a packet in a slot 2k, right. It is an even slot. So we say 2k. So the next slot will be the next will be given to the slave. The slave will transmit at 2k plus 1. Again 2k plus 2 will be given to the master. Okay. So the slave can send packets only in the odd slots, and the master can send packets only in the even slots. So that is how you have a strict demarcation between which slots are used by the master and which are used by the slave. Okay. So the whole piconet channel, if you use, okay, we said it is divided into slots, right. So you can, let us look at how this channel is used. So there are, as we said, 1600 frequency hops that are done per second with a 1 megahertz RF channel, right. So in 1 second you will have 1600 hops which are done. Okay. So now each frame that you have will consist of about 366 bits. Okay, that is the slot, and the payload out of that will consist of 366 minus 72 minus 54. Remember, the 72 and 54 are part of the header and the synchronization information that is used. So you have 240 bits. That is what is available for carrying the actual payload or the data. So 240 bits is only about 30 bytes, which is why you said small packets only are carried in the in Bluetooth. So 30 bytes is what is carried per frame. Okay, and the slots can be reserved for voice in the case of a synchronous link. Okay. And the frames can occupy up to 5 slots to improve channel efficiency. So a single frame, okay, it can occupy up to 5 slots in order to improve the channel efficiency. And you can have reserved slots and allocated slots interleaved. Okay, so that is normally done. So for instance, when you have a reservation for synchronous or time bounded information, for example, okay. So let us say you want voice to be transmitted. So voice, normally when you sample and send voice, you will need to transmit about 8 bits, 1 byte for every 0.125 milliseconds. Okay, if you are looking at sampling voice, right. I may do a sampling at a rate of 8000 samples per second, right. So every 0.125 milliseconds, 1 byte will be generated, let us say. So I need to transmit 1 byte every 0.125 milliseconds. So which means 30 bytes for every 3.75 milliseconds, right, and 3.75 milliseconds, right. So divided by 625 microseconds. Why divided by 625 microseconds? Because that is the duration of a slot. Okay. So you will find that so 1 out of 6 slots, right, so that will have to be reserved. So 6 slots will be required for that. Okay. So that is the way you will have to look at reservation of slots. Okay. And allocation, reserved slots or allocated slots, we talked about it. So reservation is normally done for synchronous time bounded slots. Allocation is done for asynchronous slots, and it is on demand. So that can be done. Okay. And this allows you to have a collision free polling, reservation and allocation mechanism. So that is the reason why we have such a detailed time slotting mechanism and frame sequencing and all these frequency hopping mechanisms which are used in piconet. Okay. So this is an example of using the SEO slots and the ACL slot, that is the synchronous connection oriented link and the asynchronous connection slots. So, you see that a master sends an SCO and in response the slave 1 responds. So, next master sends an ACL. So, let us say it sends it to slave 2, then slave 2 responds, right. Then again master sends SCO, slave 1 responds and so on. So, you can have, you will see that how the two will alternate. Okay. You can have an SCO with an ACL alternating in between each other, but an SCO occurs at a periodic rate because you need, it is a synchronous connection oriented channel, right. So, it is a synchronous mechanism. So, definitely within some amount of time, within a definite period of time, you will get to transmit your SCO amount of data, that you will get a channel to transmit the SCO data, right. So, that is basically what is, how these things are handled. Okay. So, this should give you some kind of an overview of how Bluetooth basically works. Okay. So, this is a quick comparison between 802.11 and Bluetooth. So, you can see that 802.11 also works around 2.4 gigahertz, same frequency which Bluetooth also uses. So, data rates we have 1 to 3 megabit per second and also up to higher data rates now in Bluetooth that are being supported. So, range is where we have a difference, it is only 100 meters, up to 100 meters you can have in 802.11, whereas Bluetooth is only about 10 meters. And power consumption is higher in 802.11, much lower, of the order of milliwatts, right, in the case of Bluetooth. And physical specification, this uses only basically frequency hopping, that whereas that supports many other physical channels as well. So, MAC is this here is done by means of slots. Slot allocation is a way to share the channel, whereas here we have in 802.11 we have the DCF and PCF modes of sharing the channel. Okay. And price of course lower for Bluetooth compared to 802.11, and application is mainly for short range connections, whereas 802.11 is for wireless LAN. Okay. So, we have a, you can kind of compare these two technologies in terms of what are their purposes and so on. So, to summarize, what we have looked at with respect to Bluetooth is the following. We have looked at the idea of what is called as piconet, how these piconets are formed, how the connection how the connection states are established, what happens in the protocol stack, how different messages are transmitted, and how the time division mechanism is used effectively to help the master and slave devices communicate with one another. Okay. So, this should give you an overall view of Bluetooth. We have not gone to a lot of details of Bluetooth because there are a lot more details that one could understand. So, it is kind of a complex protocol in that sense. But with this overview, you should get a feel of how Bluetooth basically works. Okay. Thank you.